Hans Stroven with McMillan, Pazdan, Smith. He's going to talk a little bit about the insight tools. How are you today, Hans?
Good. I'm doing great today, Dana. Let me
Thank
get my
you. Thank you
screen
so
all.
much for joining us. Do you want to tell everybody a little bit about yourself while you're getting looks like I got your share already.
Yeah, so my name is Hans Stroven. I'm with McMillan, Pazdan, Smith, and I'm the BIM manager, one of the BIM managers here. Just quick overview that McMillan, Pazdan, Smith is a Southeastern-based architectural firm. We've got offices in Georgia, South Carolina, and North Carolina, and I'm based in the Charlotte office. So today I'm going to be talking about Autodesk Insight. It's built into Revit itself. It's worked with both Revit and Formit. But today's focus is going to be on the operational carbon side of things and not the embodied carbon, because that just got released a couple of weeks ago, as we probably stated. And we're just getting into testing that side of things. But Insight, it's a energy simulation platform to guide and to show different scenarios that you can do within your building. Getting real-time feedback, you're able to plug in the location of it, set different standards, dial in your energy factors, and then reviewing the benchmarks via the ASHRAE 90.1 and the Architectural 2030 benchmarks. And then you're able to really dial those energy factors in to get predictive outcomes for what your building is going to behave as. And then, of course, you can then add in your members and then share with your stakeholders for informed decisions throughout the design process. So getting into this, you can start it within like your beginning stages of your site studies, doing prelim PV calculations throughout your entire building design, when you get your MEP systems inputted in, and then, of course, during the project closeout, and then throughout all the different life cycle stages of your project as well. So it's really a tool that you can review and assess at different milestone markers and whenever you need to throughout your project's life cycle. So we're going to go through the toolbar itself to begin off with. You can find this on the Analyze tab within your Revit ribbon. So first, you're going to plug in your location. This is going to specify the geographic location of your project. Then we'll dial in some of the simple or basic energy settings. From there, we can then create our energy model. And this takes the three-dimensional model and divides it up into surfaces that will actually then push it up to Insight, which we'll create with the Generate. And this creates our analytical model and pushes it up to Insights or Autodesk Insights web platform that will then be able to then optimize and access our energy levels and environmental performance on there. So once again, to begin off with, we're going to set our project address. This can either be a physical address, or you can just have the basic of whatever your city and state is. And then we'll want to select our weather station. So you can see that red pin is where the project location is at. And then the orange pin is going to be your weather station of what you have selected. To note with this is you'll want to select, or preferably select, any weather stations with the 59 in front of it. These are usually associated with airports and just have a little bit more current data. But like a lot of our projects are up in the Asheville area, so the mountain region, and your project could be on the top of the ridge line, or it could be in the valley below. So in those type of circumstances where you have more extreme environments, where weather patterns could be different if you're at the top of the mountain or if you're in the valley, you'll typically want to select the weather station that is most closely associated to your project location. So once we've got our location set up, then we can start dialing in some of our energy settings. Most of these are set by default, but going through these, you'll want to set this to the first mode will be set to conceptual masses and building elements. And that way we can capture both our model geometry and if you have any massing models in there too, because it will pull data from both ends of the spectrum. Level 1 for the ground plane, that's set by default, but if it's anything different, you'll want to update that information. The perimeter zone divisions, this is great for doing prelim modeling. So if you have massing forms in your project, this will set the offset. Like, so let's take, for example, you have a large office building. It will set your zone divisions. It'll give you your core of your building and then your perimeter zones. But if we already have a model building in place and we're doing the energy analysis based off from the model geometry, you'll want to go ahead and uncheck that. And then getting into the advanced options, the detailed model, this is associated once again with our massing. So it will take the percentage of glazing, what your sill height is, and some other factors in there to make some preliminary design options for you as well. But if you already got your detailed model already set up, you'll just go ahead and skip this step. And then we'll set our building type. So whatever the primary building will be, and that will take just assumed energy assumptions of that. So in this example here, I've got libraries set. So they'll set the operational schedule and a few other metrics in the background. So you don't have to worry about that. But that gives like a basic overview of the energy settings that you'll need to dial in just to get you going. With all of this, you can dive really into the details where you can have material properties set up for R value and U value. You can have your HVAC system set up as well, but all of that is not necessary in order to utilize and benefit from this tool either. So we'll want to then from there, once we get our energy settings set, we'll go ahead and click that create energy model. And that's going to create first your analytical spaces, which you can see all these blue boxes. It's going to carve up your building into all the different spaces or rooms of your building. And then from there, in this example video that I have going on, I'm actually duplicating this view and renaming it to analytical surfaces. And that's how I'm getting all these color coordinated surfaces that will show like the roof, the walls, the interior walls, doors, windows, and so forth. Because keep in mind that every time that you run an energy model, it's taking a snapshot of your model at that particular point in time. So if you've added or removed elements of your building, you'll want to rerun that energy model again because that's a standalone model itself that you're actually pushing up to Insight. But every time that you do that, it's going to reset that analytical spaces, but it'll keep that analytical surface view that you've set up in there. So once we've gone through and set up those basic items there, well then looking at this as a spreadsheet here. So it'll take it will divide your building up into like the roof, doors, shading devices, windows, the different floor types, whether that be a slab on grade or interior walls, interior floors, interior walls, exterior walls. And this is actually what's being pushed up to the Insights platform. So it becomes a very lightweight analytical model that's easy to work with. And that's where Revit is, or Autodesk is taking all of its calculations from. And then there's a whole list of additional categories as well that's not listed in here on this screen. So now once we've checked out to make sure that our model looks correct, we can go ahead and hit that generate button. And that's going to push it up to the Insight web platform. And then we can begin dialing in our energy factors, or what they call our widgets. And each of these pertain to different construction items, MEP items, solar, and so forth down the list. And what you're seeing in the video example here is I'm actually going through each of these cards, and you've got a graph of a range of least efficient to most efficient systems. And if take, for example, your HVAC system that you're using on your building is not listed in one of the dot markers of here, it falls within that range of things. So we're just trying to get a general baseline of understanding of what our building operational cost is going to be. These are not exact factors of everything, but just getting the generalization. That way we can make informed decisions going down the road in the future. So part of this too is once you push your model up to Insight for the very first time, you'll need to go ahead and set up your project. I'm not going to go through every step in here, but I do want to note to make sure to, depending upon which country that you're doing this out of, to set your units. By default, it's set to metric. So we'll want, if you're operating out of the US, you'll want to set that to imperial units. And then also setting that energy use intensity, switching that over to your EUI. By default, they have it set to what the cost or the annual cost of your, so dollars and cent signs, which I know not all the time that we want to present those type of numbers to the ownership or stakeholders of the project, but getting a generalization of what the EUI of the project to make we'll make long strides in order to understand your project better and what the energy demands will be. So now from there, we can then start going into the different energy scenarios and dialing in all these different factors of your building itself. So once again, the benchmark comparisons are, we're looking at the ASHRAE 90.1 and the architectural 2030. Those are built into Insight, and it will tell you where your building is going to reside at or how it compares with those energy factors. So with that, you've got a list of a whole array of different like widgets or energy factors that you can control between MEP related ones, solar related factors, construction, and operational widgets. So within each one of these cards, you'll see your EUI mean of what your building is going to, energy performance of what your building is going to be, the range factor, once again, that graph, and then you'll see that triangle. It might be a little bit hard to see on my screen right now. That represents where the Revit model is currently at. So like in this example here for the eastern facing walls or the window to wall ratio for the eastern facing side of the building, it's already taken that value out of the Revit model. So if you have information like building orientation, so if you've already set your true north value, or if it takes the if you've already got your HVAC system set up in your building, it's going to take those values straight out of Revit, plug it into Insight, and then it'll put that onto the energy graph. And then from there, you can see if you go to the left side of the graph, your building is getting less efficient. And then if you go towards the right side of the graph, your building is predicted to be more efficient. And then within each of these, the benchmark comparisons, you can see the highs and lows for your energy performance, what the mean is going to be, and then where you sit at based off from the ASHRAE 90.1 and the architectural 2030. And this is going to be specific for each one of your buildings. So just a couple of notes while you're going through this that we found in our testing is one is making sure that you, depending upon how you're modeling your building, whether that be massing or modeling, you'll want to, once again, make sure to have that mode set correctly. If you use the conceptual masses and building elements, it'll pick up from both ends of the spectrum, but sometimes you only want to examine one or the other. So make sure that you have that dialed in. Next is the project phase. If you have phasing in your project, making sure that you have the correct phase set in your energy settings. Otherwise, you'll be running energy analysis on the incorrect phase and getting some odd results popping up in your analysis. Next is the building type. Once again, you're setting this to whatever the primary building type of it, and then it's going to take pre-assumptions of that type that's selected and plug that into your energy model. And then design options. Design options aren't always used, but when they are used on the project, making whatever is set to the primary design option is what is the energy model will use when analyzing the building. And then for some modeling aspects of things is one, if you have any building envelope gaps, it's going to register, like in this example here, I've got a large, like a wall missing in my building, and it's picking that space up as shading because it's not fully enclosed, or it's not registering it as a conditioned space of the building. Next is room bounding elements. So I know at least a lot of our designers use floors as site elements. But if you are doing that, just making sure that room bounding check marks is checked off. That way it's not being picked up in your energy analysis. And this also goes for if you have, like, let's say retaining walls on your project, or if you're using ceilings or roofs for whatever various methods that are not part of the building envelope that you want to have run the analysis on, making sure that room bounding is unchecked. That way it doesn't pick it up in the while it's going through the process. And then lastly, this is something that we recently discovered. If your building is modeled too far away from the internal origin, you'll get a nice error report email come in saying that it can't run the energy analysis on your building. So paying attention to where you're modeling and how you're modeling is important to the process. But by starting off with these basics, when you're beginning your projects, it's really easy to avoid these issues. So want to quickly get into a quick application aspect of things. This is for a middle school we started testing on. It's currently the project is currently on pause, but the ownership group was interested in diving into energy analysis and seeing how it would affect their building and what factors would be at play to help reduce that operational carbon for their building itself. So once again, we went through, plugged in the building address, selected our weather station. With that too, is you're able to get some basic information like your windrows, speed analysis, your monthly temperatures, and so forth. After we've done that, we've gone through and set up our energy settings as I described before. And then click that create energy model, which then it creates the analytical spaces and surfaces, and we push it up to Insight. Once we got it up to Insight, we were able to start creating different scenarios on Insight itself. And in that way, we can then compare those different scenarios depending upon which energy factors that we dialed in, and then see how those EUIs compare to itself, and then making decisions going forward from there. So with that, we were able to then sort our widgets by their importance, determining that the HVAC, plug load efficiency, lighting, the infiltration, and the PV had the greatest impact upon the building. Now, things like construction, like the insulation, whether that be the wall construction or roof insulation, the orientation of the building, those type of things did have impacts, but much smaller scale. And depending upon the stage of your project as well, those already might be built in or baked into the process. And I mean, you're not going to be rotating your building at the end of the project, but you could be adding PV to the project to help boost that operational expenditure for it. So with that, we were able to then set up our baseline. We knew what the HVAC was and our lighting efficiency and our infiltration, our PV, at least for our PV, we've set that to 0 because just starting off with that, like we know that we may not have solar on our project. From there, we were able to then dial in those high impact items, taking that EUI down from a 96 to an 80. And then lastly, what did it take to get to that architectural 2030? So we moved some of those sliders further down to the right of the graph, dialing in, getting a better HVAC system, and then also adding PV to the project. And then that was really able to turn the dial of hitting that architectural 2030 goal. So that way we were able to then go back to the client and say, these type of factors have the most impact, and then we can then decide which direction that they want to go in. But at least we're having those informed decisions at the forefront of the project rather than on the back end of the project when things cost more. So just as a quick overview of things, this can be done at any stage of the project, whether that be in the massing, just getting your basic input on determining what your building orientation should be, how much window to wall ratio, or shading devices that you should be adding to your building. Then like what we do standard is just reviewing basic construction assemblies. We can then compare our operational impacts. And then along with that too, is we're able to report to the AIA DDX. And then if you want to take it a step further, which is not necessary, of course, but you're able to really dial in the building energy report and calculate actual energy values of your materials, your construction, and then diving, like really getting into the weeds of everything. And we're talking about like the metadata and the like digital twin side of things. And then once again, you can report to the AIA DDX for that. So, but that sums up the Autodesk Insight. Thank you.
Thank you. I'll say that was incredibly comprehensive. It really looks like you thought of everything from phasing to design options, right? Through the gamut of all. I'll say seeing some of those analysis tools in use rather than just turning off the entire section of them was pretty awesome. And of course, to see that the location is, that's pretty much the same as we've seen it since like the beginning of Revit, right? So if you're familiar with inputting the location, one question that came up that I also had a question on was on mixed use buildings. I know that we do a lot of that. Is that building type, are you able to specify that by space or is that something that's based off of the whole entire project?
So yes, you can go in and designate each of those spaces as a whatever type that is, and it gets a little bit more detailed of it. We haven't quite taken it to that extent yet. We're using just a generalized building type to get the overview of our building itself. But yes, you were able to dial into that detail level.
Awesome. Awesome. And seeing, I mean, that you can use it with the mapping tools. While I was digging for some of the, insight tokens, because nothing on Autodesk is free, right? I saw that it also works with Formit, which is cool. So for those of us who are using Formit, so lots of opportunities to use this tool, which is, just wonderful how integrated it seems right into the Revit and Revit atmosphere, just like some of what Sunhee was showing with those add-ins. So that's really great to see that all of this is becoming super easy.